Hello and welcome. In the last session, we discussed about regular expressions, and we'll be continuing of more of regular expressions today, and about web scraping and some network programs. Okay, so do we have any problem so far? Okay, did you try the program did you try to write a regular expression for validating an email address? Okay, so fine, we'll start, and going forward, I'll show you how do you write email validator regular expression in Python. Okay, we discussed about regular expression search, re.search, and we also discussed about find all. So whenever you want to figure out all the matching strings, use find all, right? Okay, and okay, so we were at find all, and let's see how do you match and extract some data. Okay, here are some examples using find all. So first of all, we do just a recap. First of all, what we do, we import re. Re is the module which process all the regular expression. Okay, then we have got a string which is my two favorite numbers are 19 and 42. Okay, we're trying to figure out the numbers from here. Okay, so this is a recap of this. We have already seen this in the last session, so I'll just go through it quickly. Okay, so 0 to 9, whatever we give inside the square brackets is going to include that. So 0 to 9, any number is going to be matched. All right, so here we have 2. So 2 is lies in this range, hence it is matched. And what is this plus for? Plus is for this match should occur at least once. Okay, remember the difference between the star and plus. Yeah, that's 0 or more, and this is 1 or more. All right, okay, and hence the result of this find all is a list of numbers, list of all numbers. All right, similarly in the next example, a e I o u, any of these alphabets in caps, remember. So if I write down capital A E I O U, it really does not match A E I O U, any of these. It is not going to match this. It's going to match only exactly the same alphabets as inside the square brackets. And plus, of course, that's for one or more times. So we do not have any of the vowels, any of these vowels in this particular string that's in caps. And that is why we get an empty list over here. All right. Okay. Now let's see what's greedy and non-greedy matching. Okay. The repeat characters star and plus. So star is for 0 or more times, plus is for 1 or more times. Push outward. Just a minute. Sorry. Okay, so all right, so yeah, let's begin again. Push outward in both directions, greedy, to match the largest possible string. We'll see how it is, how it works. Okay, so as usual, we imported the regular expression module re, and then we have got this string, okay, sample string in X, and we're trying to figure out this particular matching strings for this particular expression. And what the expression is? The caret symbol, and the caret symbol is for the matching the beginning of any string. Okay, so we'll see if any string is beginning with excuse me, any string is beginning with F, capital F, followed by any character. Remember the dot? Dot is for any character. So beginning with F followed by any character one or more times. Yeah. First, so this is how it is. First character in the match is an F. First is a F, then one or more characters, then dot and plus. This marks for one or more characters, and at last there should be a colon to mark the end. Okay, this is where our search stops. And yes, if you see this string carefully, right, what happens? We have got two colons here. So where does it stop? Does it stop here or does it stop here? All right. Since, so there's a flaw in this regular expression, right? So what it does is the plus tries to match as much as possible, right? So our question is then the search results this particular string, okay? That is, it goes till the second colon, not ends to the first colon. So why not from this? Why not it ends over here? Because we have given dot, which is matching all the characters it finds and more than one or more times. Yeah. Okay, we'll see how it can be done for non-greedy. So this is called greedy because it is it is matching the largest possible. Yeah. All right, it is matching the largest possible. What is non-greedy? Now we want to end to the shortest match. So not all regular expression repeat codes are greedy. Okay, if you add a sorry character, um, okay, all right. So what do you add? If you add a question mark over here, right? So question mark will make it non-greedy. All right, is this clear? Okay, yeah. So how do we make it non-greedy? The same thing, the same set of symbols we have used here, only an extra symbol which is question mark after the um, any character matching. Yeah. So that means question mark says that I want to find out in a non-greedy way. Okay, in a non-greedy way. So that what does it mean? I want the shortest match. I want the shortest match. All right. and hence it ends up at the first colon. Yeah. So greedy and non-greedy, right? Okay. Okay. So let's see about fine-tuning. What? Fine-tuning our search. Remember, we had used a string find method to figure out the incoming mails. Yeah. So we have taken the same example over here. Yeah. So you can refine the match for find all and separately determine which portion of the match is to be extracted by using parentheses. Okay. This is not there in this slide, but in the coming slides we'll see how this parentheses are used to extract. Note the word extract here, because the matching will be same, but the extraction will be as per user. Over and above the match. Match is done. First is match, then is extraction. All right. First is match for sure. Yeah. First you match, then you extract. This is optional. If you have anything to extract. Okay. So do you remember we had used the same matching string, and we tried to figure out the email address. All right. And more than email address, we try to figure out the domain. Okay. And how did we find the domain using the string find? That is using the split, isn't it? Using the split and giving the um, delimiter as at the rate and figuring out the. So that was in fact the double split we checked on. Double split using find. Okay. Now we are trying to see if we can do it in a better way. Right? The same search, the same extraction of the domain name or the host name from an email address from a given line of text, which is a received mail text. Yeah. So let's see how do we write a regular expression for doing the same. Yeah. So we use the same thing. Okay, I have not mentioned, but import re is going to be always there. Yeah. Then re dot find all. Yeah. What does this mean? That's for non-white space, isn't it? So that's for non-white space. Okay. So at least one non-white space character. That's plus. That's the significance of plus. So at the rate is at the center. Yeah. So before at the rate, after at the rate. Before at the rate, we need to have at least one non-white space character. Similarly, after at the rate, we should be having one or more non-white space. Non-white space is which is not a white space. Yeah. Okay. And hence we get this as output because before at the rate. So this white space is not taken into consideration, and hence our search starts from here. The matching happens only to this point because we have at the rate only here. Yeah. We have at the rate only here, and before at the rate, yes, we have got a non-white space character and number of times. Okay, so this is simple. This is very simple that we have extracted in this particular using this regular expression. We have extracted the complete email address. All right. Now let's see. So we are in the process of fine tuning. Yeah. Excuse me. Uh, We are in the process of fine tuning our extraction. All right, let's see. How can we extract furthermore? Yeah. Our matching is done so far for an email address from the text. Okay. Now parentheses are not part of the match. Yeah. Remember now, we are giving parentheses. These are the parentheses, isn't it? These parentheses, we are giving these parentheses, right? But remember, this is not part of the match. This will not be matched. Okay. Don't be confused. The parentheses are not included in the match pattern, but they tell where to start and stop, what string to extract. Okay, so our pattern is, our regular expression is the same. Okay, it is the same as before. The only change which has happened is the parenthesis. Okay, now this resulted in, this is the old one, this resulted in the email address. Okay, here is one more thing which is added. Okay, let's see that. It's like a very better match. So what's happening is, now we don't know in our previous pattern, that's a single pattern. In this pattern, we don't know whether the string is starting from, right? So that we are extracting only domain or email addresses from the received mails, right? Our intention is to extract the data from the received mails, yeah, which are beginning with from, which was not happening in this case, right? Whatever whatsoever is there, whether there is two over here, it will match this. Okay, so to fine tune that, we have given what, caret symbol and from, so that we say that now our regular expression is this complete regular expression. Okay, now we're saying our matching has to start from. So the start of the string should be from colon, and then there can follow any number of characters, any characters, yeah, that is again non-greedy. Yeah, okay, and then follows that somewhere at some point in this string, do we have any email address, right? And then note note the brackets, note the parentheses here. By this we are saying that we want to, so our match is how much? Our match is going to be with this regular expression in mind. What do you think the match would be with this complete regular expression in mind? All right, the match is going to be this, isn't it? Excuse me. So the match is going to be till here, but we are not really concerned about this from. Remember now, we are talking about two terms. We're talking about, one is match, another is extraction. That's why we said, right? We said, right, one is match, another is extraction. This is first, this is two. Now match is this much, but our extraction has to be this much. That is, our extraction has to be only for email address. So we say the usefulness of parenthesis comes into picture. Yeah. So wherever the find all is going to figure out the parenthesis start and end, it's going to extract, it's going to match the complete thing, but extract only the regular, only the string matching the regular expression which is inside the parenthesis. All right, and hence we get only the email address as the extraction. All right, now let's come to, okay, very nice PPT here. So this is from our previous example where we use the find method, right? Where we use the find string find method to extract the domain name. Okay, so we found at the rate, and we figure out the position of this at the rate at the next character. Yeah, and then we found the position of the coming space. Okay, so whatever we found between these two, we said, oh, okay, this is our domain name. Yeah, and this is how we did the slicing and figure out the domain name basically. Yeah, but that was tedious and a bit longer process. Okay, then we tried what this was the first level we tried. uh, okay, last PPT, does the colon after, okay, you've got a question here. Last PPT, does the colon after from matters? Okay, just a minute, let me go back. So okay, so okay, are you talking about this colon? Are you talking about this colon? Yeah, okay. Last PPT, right? Let me go back one more step. So, okay, we don't have a colon here. Okay, so I'll just point out, and so colon after from. So I believe you're talking about this particular. Let me just rub all these extra things, and this is the colon you are probably talking about. Yeah. Okay, great. So um, it matters. Yes, it matters because um, okay. So there's a problem with the text. All right. Now you pointed out very correctly that it matters. You know what is going to happen? It is exactly going to match from and colon. Right. So from and colon is going to be matched as it is. Yeah, so this will probably not match. There should be a colon over here in the text. There should be a colon. Then so yes, so there's a problem with the PPT here, that there should be colon after the from. You get this? Okay, so the colon is going to be matched as it is. Yeah, it's not in our special symbol list, which is part of regular expression. It's going to be matched as it is with the text, given text. And yes, the text in the given PPT has to have a colon so that it matches from and colon. All right, thank you. Okay, so we were at the find. Okay, so we saw that this was the first set of steps we did to figure out the domain name from the given text, and then we tried the double split pattern. That was also in our previous sessions where we discussed about strings. Okay, and we tried to split two times, right? First split was based on the spaces over here, so that we get these words extracted, and then from these words we figure out the first word, which was this one, and then from this we split it again based on at the rate. Yeah, and this was double split, number one split, number two split, and at the end we figured out the domain name. It was still better, but it's not best. Let's see how regex can do this. Yeah, All right, so we're saying now, wherever we figure out at the rate, wherever we figure out at the rate, we're going to start our search. So we start our search from here, and then so anything which is, so what does this uh, caret symbol inside the square bracket signify? Yeah, it says anything which is not space. Yeah, so it's basically non-white space, right? Anything which is not space. This basically negates. We saw in our last session, negates. So anything which is not space is going to be searched for 0 or more times. Yeah, and then whenever we figure out a space, we're going to stop this. Okay, so we figure out the domain name directly in this case, right? So simple, isn't it? Yeah, in a single step. So our first thing included four steps. Yeah. Second one included still further steps, double split. This regular expression version is just a single line, right? To figure out the domain name directly. All right. Now, people can ask that why we have used this caret and this, right? So it really depends on how you are going to write. There can be multiple versions of this. Okay, people can write their own versions to make a regular expression. Somebody can make a good regular expression, the shorter one. Somebody who is not really into this and will try to figure out something which works at least. Yeah. So there can be multiple versions of it, and it really depends on the user or the developer or programmer who is writing the regular expression. Okay, so this is clear to filter out the domain name from an email address. Yeah. Okay, great. Let's proceed further. So what do we have next? Next is, okay, next is the explanation, in fact, okay, which I did just now. Okay, so it really does what? Match non-blank character. Yeah, this is blank and this makes it non-blank, negates it. Yeah, and matches many of them. Okay, okay, the good thing is this. Now remember, the matching is going to be based on at the rate also. Yeah. The matching is going to be based on the complete regular expression, that is at the rate, and this expression too. The grouping, this is called basically grouping. Okay, this parenthesis is called grouping. That's called grouping. Okay, remember the naming is called grouping. Okay, this is called grouping, and this says that I want to match the complete one, but this says that I want to extract only which is within the parentheses, and hence we get only the domain name. We don't get the at the rate as the match, or because in the result at least. Yeah. Okay. Okay. And this is even cooler regex version. Why it is cooler? Because again the same thing. Okay, that we are qualifying one more thing, that we need to figure out the domain name of the email addresses which are only part of received mails. Okay, that is they begin with from. Okay, here we don't have the colon. Yeah, you see, we don't have the colon here and we don't have the colon here too. Okay, that was the typo mistake in the slide which I'm going to correct after this. All right. So this particular regex is also clear to you, okay, that this is better version because we are still uh, what is say fine tuning our search. All right. Okay. Okay, this is again the same explanation of that. We're going to start at the beginning of the line, look for the string from, skip a bunch of characters, look for an at sign, start extracting. Yeah, the starting parenthesis is for start extracting. Then what to extract? Any pattern, any string which matches this pattern. Okay, and then stop extracting. Yeah, end of the parenthesis for stop extracting. Okay, what is this? What does this program do? Have a look at this. Okay, this is basically filtering out what? Wherever we have XD spam confidence. Okay, and then following any number. Yeah, okay. So we're reading a file, okay, and in that file we are reading all the lines, stripping the white spaces at the right side, okay, and then figuring out spam, some lines which starting with d spam, xd spam confidence, and then they have got some numbers and all, right? All right, and then what we are seeing that how many such lines we have, okay, and then what we are trying to find the we're trying to find the maximum of it. Okay, just this is just a I mean just a, uh, some kind of program which has again incorporated regular expression search. Yeah, you can try doing a lot of things. The one thing which I told you in the last session was writing an email validator. Yeah, did you try at least writing, or did you see that? Okay, good question. So I believe you're talking about the dot inside the square brackets where we have written the number 0 to 9, right? Okay, so that dot is for itself. That dot does not match any character. Okay, that dot is a literal dot. All right, does this clarify? Yeah, any doubt? Okay, why it is itself? All right, because it's inside the square brackets. That's another definition of it. If it is outside it, it is any character. If it is inside the square bracket, that is inclusion bracket, right? So that dot has two significances, right? If it's outside, it matches any character other than the new line one, if it is inside the square bracket, it matches the literal dot. It's just the case of putting it inside the square bracket or outside. Gives it two significances basically. All right. Okay. Any further questions here? Okay. So uh, okay, you have another question here. The relationship between 0 to 9 and dot is or and. Okay, fine. That's or. Yeah, fine. And you know what is going to happen basically? Why it is or is that we have a following plus. Yeah. So at any point, there's going to be either a number or a dot, all right? And then again, if we, so it's a repetitive, right? One or more times. Again, if we find if the find all is going to find any number or dot again, right? So any decimal values it's going to accept. That is the meaning of it, right? Do you get it now? Okay, great. Thank you. So let's proceed with the next one. We were talking about an email validator, the last class. Okay, and we'll see how do we write it. Okay, this is a typical email validator. Okay, now I'm saying just try to understand this. So every email I suppose is going to have an @. Okay, but what can be before @ and what can be after @? So that's my assumption of it. You can write your own email validator based on your needs or your typical validation. You can even smoothen that, right? I have written a simple one where you can just see and understand and write your own. Okay. I'm saying A to Z or capital A to Z. Or so that's basically what. That's I'm telling it's all alphanumeric, right? So any alphanumeric and underscore, right, can be there one or more times. Yeah. So alphanumeric one and underscore, in fact, and underscore one or more times before @. All right. And after @, I'm saying the same thing, that alphanumeric one or more times followed by a dot. You see now your question is clarified furthermore. Another variation of a dot. Okay, to make it a literal dot here, which is outside the parenthesis, I had to use an escape. That's a backslash, an escape sequence, an escape character, right? So this dot literally matches the dot, right? If I don't use this, is will going to have another meaning or another significance out here. Okay, so that's why I have used the backslash dot here to match the literal dot. Okay, followed by Now I'm saying that my, so after dot, following the dot, I cannot have any number. Okay, as I said, that's my email validator. Okay, you can write your own based on your validation points. My email validator is going to validate any such email, right, which has alphanumeric and underscore before at the rate, and followed by that, like again alphanumeric one or more times, but then a dot is a mandatory, right? Dot is a mandatory. It's like a hard-coded match. Okay, and following the dot, I cannot have any number. I'm allowed only alphabets. All right. Now you can try to run this on different parts, on different text files which have different sort of email addresses, and try to see whether it really validates or not. Okay. Okay, we are again at the revision of it. So always keep this quick guide with you. Okay, until you are thorough with all the symbols out here. Okay, that's a quick guide. Uh, okay, we've already seen the what you say significance of this backslash. That's the escape character. Okay, so it really matches dollar, little dollar. Okay, this one is a little dollar. It's not going to it's not going to treat it as any regular expression, special character or symbol. All right, great. So here we come to the end of our discussion on regular expressions, and we discussed about uh, many types of regular expression. There is a lot to discuss in regular expression. It's a vast subject in itself. All right, but as part of this course, we do not have the time or bandwidth to discuss about all these things. Okay, so, and we discussed very important usages of regular expressions. Most of the times you would be doing regular expressions on from one of these listed down quick guide points, but there will be some times where if your uh, project or application demands a lot of regular expression, you will have to explore yourself a lot. Okay, but I hope that this gives you a very good base to start with regular expressions at least. Okay, so we discussed about regular expressions, how powerful they are, their language into themselves, and what are the special characters and how do we use them. All right, so before moving further, do you have any questions for me? Okay, great. So we are going to begin with another session today, which is going to be on some network programs. All right, let's begin with very simple things, and we're going to discuss very interesting, but there's going to be more of theory today. All right. Um, I'll try to show you some demonstration wherever possible. All right. The rest you can, so the course is updated on the website. There was a lot of mismatches and things were not shared properly, right? So I sat together with the web development team, okay, and we have updated the exact slides and the videos and the presentations on the website so that it is visible to you guys, with the same slides we discussed here. and with the inked part. Like sometimes I keep write and penning down, write some things. So you'll be able to see those things also on the slides. Okay. Um, Great. So, if you have any questions, so you can go through the course, your course login thing, and see if anything is missing. You can let me know. Okay. All right. Great. So let's start. What we are going to discuss is very simple concepts on networks, how requests are done to the servers, how things are fetched from the servers, how web scraping is done, how you get some items from the web and parse them and figure out things. All right, so here we have a simple client and server which are connected over internet. Okay, now what can a client have, right? What can a server have? There can be many things. There could be HTML, Ajax, JavaScript. So, and in the internet, what you see over here in as a cloud, you can do a GET request, you can do a POST request. Okay, you can create a socket. Okay, so that's internal part of like how you create the connection between the client and the server. Server could be running some maybe some data store, or so what the server could be anything out of this, right? Okay, so that's a very simple picture of it. A very simple part of TCP, protocol. Okay, what does that signify? Is transport control protocol built on top of IP. Okay, so it assumes that IP might lose some data. Yeah, so TCP is a reliable one, right? Whereas UDP is unreliable. All right. So it assumes that IP might lose some data, and hence it stores and retransmits the data if it seems to be lost. We're not really not going to go through the very internals of frames, packets, and how things are done in networking as such, but we're going to cover very small basics of it, which will help us to understand how we are going to get data using the Python modules or libraries, and there might be some cases where you get some doubt on very basics of it. That's why we have covered some things on that part. All right, so as we said, TCP is going to retransmit if it seems to be the packet seems to be lost. Okay, there's a flow control which is handled by TCP. Okay, and it's as we said, it's a reliable connection, reliable pipe. All right, and the source, whenever I see, you can find out the source where I have taken up the things from. Okay, so there are a few things which I have taken from some Wikipedia pages, so you can just uh, follow these links to get further idea on how things are, right? Okay, this was we have seen it in many old movies, and how people used to communicate. It's a fun device, right? A tin can telephone, yeah, used to communicate. What we are discussing is the latest form of communication now. All right, so how do you create connections or sockets? Right, so this is a very precise definition of the socket, right? In computer networking, an internet socket or network socket is an endpoint of a bidirectional inter-process communication flow across an internet protocol based computer network such as the internet. Seems very complex, but it's easy, right? Socket is nothing but it's an endpoint of a IPC connection point, right? So there are two processes out here as shown in the picture. these processes want to communicate to each other, right? And they are connected using a socket. That's a socket connection, right? Right. And what a socket is going to have is also a port associated, isn't it? So over the internet protocol based computer network. So over any IP based computer network, any process is communicating, they create a socket, right? They communicate over the socket. So we have got something called port numbers. What are port numbers? A port is an application specific or process specific software communications endpoint. Yeah. So that software specific endpoint, okay, is the port. Okay. And that's basically application specific, right? So each process is going to communicate over a specified port. All right. It allows multiple networked applications to coexist on the same server. So the same server can have multiple processes, multiple applications which can communicate to multiple processes again on the other side. Yeah, there are some well-defined port numbers, okay, which are listed out here: 25, 23, 80, 443. Right, so I think you might be knowing about all this. So have you done this course in your school, which talks about the network or programming or something? Yeah. Okay. Oh, not yet. All right. So maybe you might find it very interesting then. Okay. So do you want me to repeat anything so far, or so far it's clear? It's clear. Okay, great. So we did what? We created the socket, we had the port, and now things are going to be communicating. The processes, applications are going to communicate over these port numbers. So there are some well-defined TCP port numbers. Okay, like the request in the slide is saying that, hey, please connect me to the port number 80, right? So I want to connect to a server. So I'm saying that, hey, I want to connect through the port number 80. All right. Okay. So, and what is this? Do you see? You see over here, right? So that's the website of, I think that's University of Michigan. All right. So that's the website of University of Michigan. Okay. And we are saying that, hey, that's the port for incoming mail. That's for login. These are for web servers. Okay. Their personal mailbox, and these are the machines which are trying to access all those things from this web server, right? Okay, so these are very common TCP ports over which the communication happens, like for SSH 22, Telnet 23, HTTP is what we are going to focus on today. That's why it is highlighted. All the HTTP communication happens over port number 80. All right, HTTP, yes, the secure HTTP connection is 443. The SMTP, the mail one, and the mail retrieval systems, IMAP and POP, have different port numbers. DNS and FTP. All right, so you can go through this if you are interested in some other port numbers and writing some programs for them. But we're going to focus mainly today on the HTTP part. Okay. Okay. Sometimes we see the port number in the URL if the web server is running on a non-standard port. It's not always, but if your server is running on a non-standard port, You see the port number over there? So that's the port number 8085. Okay, 8085 is the port number over here. You might find it on some web links. Okay, how do you create a socket in Python? Python has built-in support for TCP sockets. Okay, the module is called socket, and let me show you if I have anything over here. Okay, so if I talk about socket, so I can say import socket. Okay, hey, that's there. So that's why we said that Python has built-in support. Yeah, that's called built-in. When we don't have to install any. I have not installed any third-party module called socket. That's the built-in one. Okay, I've got the socket module. Now next, what do I do is that um, I'm trying to create a socket object. Yeah, now, so my sock is socket. So this is where I'm trying to create the socket. Okay, and whatever you see here, that's socket.af. That's the type of the socket you're trying to create. So there are various sorts of the sockets which you can create, which is down there in the link here. If you follow this link, you're going to, okay, let me try to open this if this works still. Okay, all right. Okay, so that works, right? What do I have over there? That socket low level networking interface. If you go down here, you can figure out that, okay, okay, here it is. So we have used one of these. Let me minimize this furthermore. Okay, more. Okay, place it over here. Now you see we have used socket.afinet. AFINET is one of these. These constants represent the address and protocol families used for the first argument to socket call. Okay, so the socket function is going to take this any of these as the first parameter. If the AF Unix constant is not defined, then this protocol is unsupported. Okay, so you can try out on these different things. You can create a socket connection giving multiple variations of these. What we have created right now is an inet socket. Okay, you can create inet 6 also, and the second argument is this one. We have created a stream based socket. Okay, these constants represent the socket type, okay, used for the second argument to socket. Okay, so that's saying only sock stream and sock dg ram. Okay, uh, they appear to be generally useful. Okay, what happens if we create a socket? That means our connection, so that socket is in a working condition. Okay, we can try to create a connection based on this socket object. That's the next step. Okay, once we have defined that this is the type of socket I want to create. Okay, once the socket object is there in place, I can say my sock dot connect. I want to connect on this socket to what? To this website. Py for inf .com, and on the port number 80 I want to connect. Okay, it tried to connect. You saw the lag, right? You saw the small lag when I was trying to connect to this. So what if I try to connect it over again? You see, we get an error. A connect request was made on an already connected socket. So there is already a socket connected. Somebody has already connected to this socket. Okay, so we cannot connect it again until we close the socket. Okay, so this is a very basic of connecting or creating a socket in Python. Going forward, we are going to see how it is used. Okay, as of now, what you need to take from this slide is how do you really make use of socket module to create a socket and connect. That's it. The further things we are going to see, how do we close the connection, how do we get the data and all, so on. Yeah. What we simply did is created a socket object and connected to a particular server or a website on a particular given port number 80 in this case. All right. Oh, some fun part. Now this person says, how are you flying? How? You're flying. How? That guy says, Python. You see, so I learned it last night. Everything is so simple. Hello world is just print hello world. Yeah. Now this guy is saying I learned it last night. Yeah. Okay, this guy is now saying I don't know. I don't know dynamic typing, white space. What is this? Come join us. Programming is fun again. It's a whole new world up here. But how are you flying? Okay, so he replies, I just typed import anti-gravity. All right, funny, right? He just said import anti-gravity and he's flying, right? Okay, so that's really it. You know, you have really a lot of things to do in Python. Just say import and your things are done, right? So he just said import anti-gravity and he's flying now. All right. So okay, that's the fun part of it. But it really it is, you know, it is really simple, as simple as that. Okay. Let's see again the same thing. Now when we created a socket, what do we really want to solve? What is it we really want to figure out by creating a socket? Okay, so we want to do what? We can do something with mail, World Wide Web. There are many things which you can do with, you know. So most of the things we'll be doing with is application level protocols. Okay, let's see application level. So you see the layer. I hope you are aware of the TCP protocol or the OSI model. Have you done that part yet? Yeah. So, I mean, are you aware of the basics of, okay, you're not done yet? All right, so that's like, you know, I'll just explain in a very simple terms that here is we have, so you see this particular stack over here, okay, that stack and this stack. These are the two machines, okay, these are the two machines. That's machine one, that's machine two. They're trying to communicate over internet. All right, and whatever you see over here, that might be somewhere, you know, your modem or router or switch or so on, right? The devices over which the data is going to the correct points. Okay, this machine wants to talk to this machine. Okay, That's this stack what you see over here. The layers which you see over here, 1, 2, 3, 4, right? These are the layers from which the data flows, right? So say for example, if I talk about machine 1 sending some data to machine 2, okay, that is what, see, this is what is going to happen. You open up a browser, okay, you open up a browser, that browser is over here, okay, that's at this point where the application is written, that's in the application layer. We call it a layered model, right? So these are the layers which you see over here: the application layer, the transport layer, internet layer, link layer. All right, so in the application layer, you open up a browser, okay, type in a web address, okay, which is probably at machine 2, okay, and you're trying to fetch some data by sending a request. The request is sent on these, and the request goes in this direction, down direction in this case. So it goes from the transport layer and then the internet layer, then the link layer, and then the physical path from where the data, your data is going to flow. Yeah, and then when it is received, the data is received here, each of these layers will be adding up some headers, okay. So these will be adding up some headers, 1, 2, 3, 4, okay. And whenever the data has reached to the destination, the machine 2, it chops off these layers, these headers, sorry. So these headers will be chopped off one by one, and at the end the data will be received. So this is like data plus header will be sent, okay. These headers will be the identifiers to tell them that, hey, this is your job, this is what I have got for you, and please try to extract the data. Yeah, so TCP is a, it's a protocol, it's a layered protocol where it's used to communicate to different between machines in the internet. Yeah. All right, so you can go through this, the links which are there in the slides. They will give you a brief idea on these all of these protocols. Okay, as of now, what you can understand is we are talking about some protocols which are used to connect to different machines, and they can talk to each other, creating a socket over a port number. All right. Okay. Okay, now we are talking about there can be many protocols in each of these layers. Okay, now when I'm saying that I'm talking about the application layer might have a lot of application level protocols. Okay, and that's what we are going to discuss now. Application level protocol, the protocol is called HTTP. That's the application level protocol. Okay, let's go through this now. Okay. So HTTP stands for Hypertext Transport Protocol, the dominant application layer protocol. That's the dominant one. Wherever you see, you can find out whatever web request you send, you'll begin with HTTP colon slash slash www dot something, right? So that's the protocol part of it. Okay. Again, Wikipedia is a very good friend of all of us, right? And we should read Wikipedia for any sort of information. That's the, you get the exact information of thing you are looking for, right? Invented for the web to retrieve. So HTTP was invented for the web to retrieve HTML, images, documents. Then it was extended to be data in addition to our documents, right? It was then worked with RSS, web services, and so on. Okay, what the concept lies behind HTTP is, the working concept is very simple. Okay, you make a connection. Okay, I've got your voice back. Yeah.
Yay.
I can hear you now.
Okay.
Okay, great. So the concept lies is very simple that you make a connection, you request the document you want to, right? And you retrieve the document. So you make a request. If the request is good, if the request is valid, you get the document and then you close the connection. It's as simple as that. All right.
Mm.
Okay, so let's move forward. This is again, a very formal definition of it that HTTP Hypertext Transport Protocol is the set of rules to allow browsers to retrieve web documents from servers over the internet. Okay, what is a protocol? We have been talking about a lot of protocols, TCP, HTTP, and all those stuff like protocol. What is a protocol? Protocol is nothing but a set of rules that all parties follow. So if we do not have a rule, we're going to get into mess, isn't it? So, and we don't conflict with each other. Say we are communicating. If I don't speak in English now, if I start speaking in my mother tongue, or some other language which you do not understand, there's going to be a lot of conflict, isn't it? Yeah, so we agree, we both have agreed on a protocol, right? We both have agreed on a set of rules that hey, we are going to speak in English. Yeah. So that you understand what I say and I understand what you say. All right. So that's what, like on two-way roads in USA, drive on the right hand side of the road. On two-way roads in the UK, drive on the left hand side of the road. So everybody in UK follows this, everybody in US follows this. Yeah. If they do not follow, they're going to get into mess, isn't it? So we all have to follow a set of rules so that the communication is better and effective, right? That's the meaning of the protocol, that it's a set of rules that we all follow, right? All right. So as we said that um, okay, as we said that when we make a request. Okay, you see HTTP, you signify like this, right? You tell the request, web request like this, HTTP colon slash slash. So that says that what is the protocol you're using to um, make a request to the server, right? And that's the host, right? You want to connect to, and that's the document which you are trying to fetch, right? These are like pieces of your HTTP request. It's a typical HTTP request is done like this, and that's the meaning of the parts in that. So you have the protocol, then you have the host, and you have the document which you're trying to fetch. All right. Now, how do you get the data from the server? Each time when the user clicks on anchor track with href is equals to value, to switch to a new page, the browser makes a connection to the web, right? So whenever you click to a hyperlink, right? So what happens is the browser tries to create a connection to the web server. To the given web server, the browser is trying to, so browser is what? Is your client, right? And the server is server, right? So web server is your server. So client, that is the browser, is trying to make the connection to the server, web server, and it issues a get request, okay, because it wants to what, href, right? We want to follow a hyperlink, we want to get the content of the page at the specified url. So whatever url is in the hyperlink, we want to fetch the data at that link, right? And that is why the get request, okay. Whenever we want to post anything to the server, the client will send a post request, right? Okay, the server returns the HTML document to the browser, okay, which formats and displays the document to the user. So who does the formatting? it is the browser which does the formatting, isn't it? Browser sends the request, server returns the HTML document. Browser is the one who is trying to format it and display the document in a well formatted way. If the browser does not do that, you know how the data is going to look like. You will see in the following slides. It's really messy, right? Okay, so let's see how it works. I'm trying to connect to the server like www.drchuck.com. Okay, so first of all we make a handshake. That's the connection part of it, right? Handshake, by handshake I mean the connection. Yeah, that's the uh, part of making a connection. Okay, once the connection is done, I'm going to request for the document, right? Like this. Why I've made this or the default document. Say for example, if you do not give the document name, maybe probably you end up getting a default document. We'll see how you get the default document if you don't mention any document like page1.html. Hey, I'm trying to get page1.html from this particular server, right? That's the get request. That's what is the get request. Okay, so this is how it is going to be pictorially, right? So that's the first page you are at. Okay, and you have got a hyperlink over here. You have got a link which is in the blue one, second page. You are at the first page. You want to move to the second page. Sorry. So what do you do? So browser makes a connection to the web server over port 80. Okay, then and after making connection, what it says, it gives a get request. Okay, it commands a get request. The web server gives back the HTML because what it has requested, the the web browser has requested for page2.htm. That's the HTML, right? So the server is going to send the result as an HTML, right? That's an HTML. But what do you actually see? Do you see like this on your web page? No. See how beautifully your web browser is showing is to you, right? So basically this web browser is parsing, parsing and formatting, right? And doing all those stuff so that user is able to see in a very pretty way, right? In a beautiful way. Okay, so you understand the basic part of this HTTP request now, how the request is done and how the connection is made over the socket. Yeah. Okay. Good. That sounds good. And let's proceed because we are going to do very fun stuff after this. That's called web scraping. The part one of it today. Rest of it we'll do in the next session. All right. Great. So let's move on with next thing. Okay. The internet standards. Okay. So we have got some standard for all these protocols. The standards for all the internet protocols are developed by an organization. There is an organization which is called IETF, Internet Engineering Task Force, which looks over at all these protocols and development of it, right? And these standards are called RFCs. Okay, requests for comments. I'm really not sure why this name was given. So it basically misleads. Like I don't find any useful thing on request for comments. but this is the name which is given to the standards. In fact, HTTP protocol has got a standard that is an RFC, right? So if you see over here, the RFC 2616, right? If you go to the link shown here, and if you see, you can find the details of all the things in the HTTP protocol, right? So this gives a very, official. This is an official document, right? So you can see the description of the HTTP over here. HTTP hypertext transfer protocol is an application level protocol. So you get all the things over here, right? How do you do a request? What is meant by a request, and how a request is defined, a request line is defined, and so on, right? You can go through this when you're free. You're interested in this, you can go through this RFC, and you can in fact go through other RFCs which talk about the other protocols. Okay, okay, this is how we did in the HTTP request in the previous slides. Okay, okay, this is one more important aspect where we are doing the connection on a telnet port. Okay, I don't have the setup for demonstrating this, but this is pretty much like is mentioned on the page in the slide. Is done like that. Okay, what you're trying to do is you're connecting to this server. Okay, you're connecting to this server. So what it says is trying this IP address of the server and connect it to this, and once the connection is done, you're doing the get request, right? The get request for this particular page 1.htm. Okay, and here is the page you get, right? Here's the data, basically. That's the HTTP response. So this upside is the request, the downside from the server, what you get is the HTTP response. The response comes in the form of HTML. Since you requested for the HTML, the server has got HTML, it sends it back to the client. Okay, that's not sort of really hacking the HTTP, because you're trying to. Okay, that's saying that we're not doing it from the browser. In fact, internally browser might be doing something on this part. So you might have seen this hacking, accurate hacking, in some movies like Matrix and Die Hard and so on. You see a typical screen and an agent doing all sorts of hacking and getting into somebody else's system and extracting data. Right. That sounds very interesting, but it's a difficult part to do. Not like what you see in the movies. Not as simple as that. All right. Um, great. So this is like the complete part of it, where you can see the connection closed also by the foreign host. What do you mean by the foreign host? Where you try to connect, that is server part of it, or the other machine, right? Once you're done with this thing, the connection closes. Okay, that was pretty much like where how do you get the data? You create the connection, you make the connection, and you do a request. Okay, the server sends you a response. Okay, and you close the connection. When you're done with the data, you get the data. All right. Okay, here I have got the I don't know how it looks like. Maybe I can just have a look at how this thing looks like today. Michigan. What's the website? Okay, I'll have to see what the website is. What is this web address? Okay, that's UMICH. All right, that's UMICH. Yeah. That's the one. Okay, let me see how does it look like today, because the slides are a bit older and there might be a lot of development on this part. Okay, it's pretty much same. Some parts are different. Okay, all right. So that's the website of University of Michigan, and now you've got a lot of data in this. Okay, what you're trying to do now is the same way. We are going to do telnet on this website. Okay, we're making a connection to this, and then we are doing get slash, right? That's the get root. So that gives you the default document on what's there on the uh, University of Michigan's homepage. All right, homepage, and it says clearly, right? University of Michigan is one of the top universities of the world. Okay, a diverse public institution of higher learning, fostering excellence in research and so on. All right, so that's the default page you get, and you see this stuff is messy, isn't it? You really cannot understand if you don't understand the HTML language. All right, so that's why we have got the browsers making the request and prettifying it and showing it to the user, rather than we going as intruder and figuring the data out. Okay. And in fact, what happens is HTML has got other links embedded in it, right? So like the CSS, whatever you see in the violet color are the further links where browser, you see, as the browser reads the document, it finds other URLs that must be retrieved to produce the document, right? So browser internally makes these requests, whatever you see in the violet color, and then as I said, it prettifies it, gets the document completely and displays to you to the user as a pretty page. All right, that's the bigger picture of it, right? So whatever text you see on the right hand side, right, and so that's like, that's the web page of it, right, the HTML form, and this image is like this, right? The data of the image is like this, which is converted to this image by the browser, right? I would really personally would not be interested in such sort of data, whereas this is a good one to look at, right? Okay. Okay, so browser debugger reveals details. Most of the browsers have a developer mode so you can watch it in action. It can help explore the HTTP request response cycle. Yeah, so you can use your browser. In fact, the Chrome browser has got a very nice debugger in it, where you can look at the page pieces. You can look at the source of an image or a link or functionality of the page. Right. So browser is a good debugger nowadays. All right. So let's write a web browser. How do you write a web browser? What typically a web browser should do? What do you think? Right. So a web browser typically has to make requests, isn't it? Yeah. What do you think? Yeah.
To make request, connect to server, and translate the original code.
Yeah. So a web browser should basically make a create a connection, right? So first it should make a connection and then do a request, isn't it? Do a request, get the response, prettify it, and display it, right? Okay. So can you hear me, Ann?
Yes, again.
Okay, okay. Great. So let's see how it is written. So that's pretty much of a very little web browser sort of code, right? It's really not a huge web browser. It's just a small part of implementation of it. So what do you do basically? As we said before, we create a connection. How do you create a connection? Make a socket and get the socket object, connect to the given website you want to connect to, and give a get request. Send is the method using the socket object. That is socket object, and you make a send request. I mean, you do a get request and send the get request, right? This is the send part of it. Okay, so that's pictorially, that's your computer, my computer, doing a send request over the socket. Yeah, send request goes here. Web server receives the send request, receives the get request, and what it does is it gives the response as the receive part. So my socket would be listening to this port. There is something called listening to the port. Do you understand by listening?
Yes.
So it basically is always listening on the port whether I have received some data or not. Yeah. So as
Mm.
soon as there is, so that's why we have done this in a infinite while loop, isn't it? So this while loop is always listening on this port. Okay. Whether we have got a data or not. If the length of the data is less than 1, we're breaking out of it. That means we haven't received anything from the server. Otherwise, we print the data, right? And this is the close connection. This is pretty much it, isn't it?
Mm.
This is pretty much you want to do as a simplified web browser code. There are a lot of improvements in this, but we're not concerned about that. We are just talking about the basic part of it. Okay, so let's see what do we get. This get request. Okay, let me try to see if I can run this. Keep and oops, copy and paste it in a file. Okay, I don't know if this website is still up. That's the old slide. Let me just see if this works. So I would name it as web browser.py. Let me try to run this. Oh yes, it works. You see that?
Yes.
You see some output over here, right? So that's basically coming from the web server. Okay. What's the web server? That's pi for inf.com. But soft word light through. Okay, let me just open that. I don't know what's there on this part. Pi for inf. Okay. Okay, and it has fetched. Okay, some part of it. What was that? In fact, let code romeo.txt. Yeah. So where is romeo.txt? Yeah, that might be somewhere inside this part. Okay. If I try to open the same things, code. Okay, here it is. Okay, and this is what we have got. Yes, right? So, but soft what light through yonder window. I'm very bad at poetry. Okay, let it be. All right. Okay, great. So you see how we make a make a socket and do the send and receive. All right.
Yeah.
Now let's try to make it a bit easier. There's a library which is called URL lib. which I have not installed. I would suggest you to install this on your system, okay, and try to run the program which we have on this on these slides, okay.
Mm.
All right, so just go and download this URL library. Okay, so HTTP is very common. So we have got a library that does all the socket work for us. We don't have to now worry about all the socket creation and do a connect and close and all those things, right? So this URL lib has done this work for us. What all we need to do is that import this URL lib, okay, and do an open connection on the direct page you want to get the port. So it's like a file, right? You give a request. That's the get request, in fact. Okay.
Mm.
For this page, Romeo.text. For the Romeo.text, I'm getting the file handle. That's nothing but a file kind of object returned to you. And it's as simple as that. You loop over in the file, right, and get the data, as simple as that. This looks very pretty, isn't it? You don't have to worry about sockets and all. You just do a URL open on the link
Mm.
you want to, get the file handle and read it. Yeah,
Yeah.
and that's the, as I said, right, so I have mentioned all the links where I have taken the data from. Okay. So this
Mm.
Romeo.text is not mine. All right, that's taken from some other links. Okay. Uh,
Mm.
so the reference links are mentioned over there on the slides. So you can just browse through them. Okay. Okay. That was the same thing. It's like a file. So can you tell what this program is doing? The violet color one.
Mm.
If I say that f hand is a file handle, what is this part doing?
Uh, word count.
Exactly, great. So that's counting the number of words in the Romeo.text file. Okay,
Mm.
great, fine. Okay, now we have a difficult thing. Okay, as you see now, we have been making request for the text file. Is it
Mm.
right? Now, what if we have an HTML page to request for? Okay. Now reading web pages. What if we have HTML, right?
Mm.
You know that HTML doesn't look good, right? It doesn't
Mm.
look really very, very good. It has got a lot of tags and all those stuff, right? So I would
Mm.
really not be interested in getting the HTML. Rather, I would be interested in the parsed form of it, right? So what if
Mm.
your data is in HTML form? You read it, of course, using the same sort of code, that is import URL lib and do a open URL open on the page and get it as a file and read all the lines, right? But still what you get is an HTML, isn't it? Now that file is no more .text, right? So what you get is just
Mm.
plain text file, right? But that's in the form of HTML. Okay. So, and what if you want to go from one page to other? Okay. So again, you will have to do what? The follow page, isn't it?
Mm.
See, something you have to do. What has to be done is, if the HTML has hyperlinks, correct? If the HTML we have received from the server has got hyperlinks, we will have to follow these hyperlinks to get further data, isn't it? So for that, we will have to parse this HTML. Am I right?
Mhm.
Okay. So we'll see how it is done. Okay. parsing HTML, also known as web scraping. Okay, so let's go to the formal definition of web scraping. When a program or script pretends to be a browser and retrieves web pages, looks at those pages, extracts information, and then look at more pages. So you know what you're doing is you're going to a page, getting some data, going following some other page, getting some more data, extracting the data. This is in fact called web scraping. All right. So, and you know, there is a difference between web scraping and web crawling, right? Crawling is just, I mean, as the name suggests, right? So what Facebook does is when you do it, it makes friends suggestions for you, right? It gives you suggestions to add some more friends, which are friends of your friends, right? That's what is meant by the crawling of the web, right? It's crawling, it's getting all the data and it's making suggestions to you. And where we are parsing the data, extracting some more information, that's web scraping, right? There's a lot of things to it. Okay, you can go through the Wikipedia and learn more about how crawling is done and scraping is done. Okay.
Okay.
Okay, so what you do is this: get is the get request. What is this get? It's the literal get request. You get the HTML as the response, and then and in the code that's in the browser part, and the code part that's the get request, right?
Mm.
This is the get request, and here is what you have got the HTML as the response, right? But now what happens? How do we parse now HTML? See, we have received all the data from the web, right? The text file, the HTML files, but now text file is fine because I really not interested in parsing the text file further because I believe there is no further useful information in the text file, right? To go further and fetch more data. But in the case of HTML, there's going to be a lot of useful, hyperlinks. There might be. I might have to follow those to get further data. I would be interested in getting some data and understanding the HTML too. Okay, and we'll be seeing how do we, beautifully do that. So why do you want to scrape? Pull data, particularly social data. Who links to who, right? Get your own data backed out of some system. Right? Monitor a site for new information. Okay, okay. So basically, you're getting a lot of data, right? And at the end, you would also want to do data analysis. That's again a very good part done these days, making useful reports out of the huge data which you fetch. Okay. So what? So what if you try to scrape over Facebook? Do you think you're going to get some trouble?
Mm.
So say for example, you're trying to fetch data of your friend, okay,
Mm.
from Facebook. Okay, one of your friends, she's in Facebook, and you want to get some data, right? And you
Mm.
get the data and you find the in the result data that hey, this friend of mine is again connected to one of the friends. Let me try to get the data for that too. And and coincidentally you figure out that hey, I know that guy also, right? You end up getting a lot of data and you say that hey, let me try to post an email to this guy. I have not contacted this guy from a long time. Okay, that's the what violating, right? So
mm,
probably Facebook is not going to allow, and it has got good algorithms in place to figure out these things, that somebody is trying to scrape our data and misuse those, right? So
mm,
it might
mm,
try to block you. Maybe, I'm not sure, but that's kind of in the line of violating terms of service, isn't it?
mm,
So scraping is good, but misusing the scraped data is not good.
mm,
All right.
mm,
So this is like I was talking about, right? So if you read this user conduct on the Facebook page, and you would find something like, in addition, you agree not to use the service or the site to harvest or collect email addresses or other contact information of other users from the service or the site by electronic or other means for the purpose of sending unsolicited emails or other unsolicited communications, right? So we do web scraping, but for the useful purposes, isn't it?
mm,
Okay, okay, here we have come to the easy way. We said, right, we want to read out the HTML in a better way, right?
mm,
Okay, so this is a very good software that's called Beautiful Soup. That's, you can find out in the given link, crummy.com. Okay,
mm,
and what you need to do is that just place the beautiful soup.py in the same folder as where you're writing the web scraping code. Okay,
mm.
so you place your Python
Folder?
code. Yeah, come again.
In which folder as your
Python code.
Python code?
So Python code means, say for example, my script is called scrap.py. Okay,
Mm,
and that's in the folder A. Okay,
mm, mm,
so I'm going to place this another file called beautiful soup.
um,
Beautiful soup.py, that you can find in this link.
mm,
Okay,
okay.
that's like a module which you are going to put in the folder where you are writing the web scraping code. Say for example, you are scraping data from Facebook. Okay,
Mm,
and that code is written in the scrap.py which you have given here, one file. Okay,
mm,
so because this is going to import this beautiful soup, we'll see this further. Okay, but here it is,
mm,
right? So what you're doing is you're making use of URL lib and beautiful soup both.
mm,
Okay, so
mm,
what you're doing is taking the URL as input where you want to perform the web scraping, right?
mm,
And read the data, HTML data, correct?
mm,
So you're doing what? URL open. Okay, URL open on the URL dot read will give you as a file complete text. Okay,
mm,
now
mm,
this HTML file you're going to pass into beautiful soup method. That's a function. Okay, now this function will, what it will do is, see, retrieve a list of anchor tags. Each tag is like a dictionary of HTML attributes. Okay, so
mm,
soup is the method which is going to find out the tag number A. What is this? This is a tag. Okay,
mm,
that's going to find all the tags inside the tag A. Okay,
mm, mm.
and it is going to see if we have got anything with href. That's the hyperlinks. Okay,
Mm,
so we are figuring out all the hyperlinks in the A tag, inside the A tag. correct? Do you get this?
Mm,
In doubt?
no.
Okay, so
Okay.
what Beautiful Soup is doing is it is
Mm,
making your task of reading the HTML easy. Okay,
mm,
so what you need
mm,
to do is just go through this link, crummy.com
mm,
software, not software. If you go to crummy.com and see the documentation of Beautiful Soup, you will figure out how easy it is to parse the HTML
mm,
using Beautiful Soup. Okay.
mm. Okay.
Okay, and this is like you can just simply give the tag name where you want to start your search for.
Mm,
Okay, and within this tag all the hyperlinks are figured out. Okay, you see here it is.
mm,
Okay, whatever is there, you see this is my tag A. You see here
yeah.
between this tag I've got one hyperlink, isn't it?
Mm,
So this hyperlink is extracted.
mm,
This hyperlink is printed. Now what you can do is you can write further code to URL open on this hyperlink, isn't it?
mm.
So using URL lib and Beautiful Soup, web scraping is very easy. All right.
Mm,
Now what I would say is try to install both of these, okay, in your system, URL lib and Beautiful Soup, and try to figure out, uh, try to just execute this program which is there in the slides. Okay, if
mm.
this simple scrapping works, we are going to do a small project on this. Okay.
Okay.
Okay, so just try to have a look at Beautiful Soup and URL lib. Okay, try to execute the small code which we have mentioned in the slides. All right,
Mm.
I'll be
Also,
I'll be sharing these slides
yeah.
with tomorrow. Okay,
Okay. Okay.
okay, tomorrow morning IST you'll get that.
Okay.
Yeah, anything you were saying?
What's the in the get function? What's the noun mean in the parentheses?
Where is that?
Print tag
Okay,
get.
none, right? So
Mm,
that's like uh, okay, so you need to see. Um See, every method has got multiple parameters, right?
mm,
This
mm.
parameter we are not specifying, that's why we have given as none. Okay,
Ah,
we are not giving this
mm,
parameter any value as of now. Okay, and we want that this parameter should take default value, if at all, right?
mm.
That's why we are explicitly giving none.
Okay.
So this parameter internally get method and the second parameter might be having a default value of something, right? But we are
Mm,
overwriting it to say that no, I don't want anything for this parameter.
okay.
Okay, so
Okay.
and that's why I'm telling that you just go over and see there is a very beautiful documentation for all these modules, that is URL lib and Beautiful Soup. Just try to
Mm,
figure out your way to scrap some data.
okay.
Okay, and I will tell
Okay.
you as a small project what do you have to scrap and get back to me. Okay,
Okay.
uh, probably by next session and end of the next session you're going to get what you need to do as a part of the project. Okay,
Mm,
and we
okay.
are going to meet for the last session which will be like discussion for on this project and what are the problems you faced and how much were you able to do that, right?
Okay. Okay. Mm.
Okay, so here we come to the end of the session today. So we discussed some theoretical things, not much of hands-on, but a lot of theories today. So we discussed about TCP, IP, HTTP, and HTML, web scraping, parsing, right?
Yes.
In the next session, we are going to discuss further about web scraping. Okay, uh,
Mm.
a little more things, and yeah, some more things to follow. Yeah. So,
Yeah.
any doubts so far today?
No.
Yeah.
Mm?
Do you have any doubt?
No.
No. Okay, great. So, thank you very much for joining in today.
Thank you.
Okay, see you in the next session.
Yeah. See you.
Okay,
Thank
bye bye.
you. Mm. Happy New Year.
Happy New Year to you too.